Good morning, good afternoon, or good evening, depending on where you're located. I'm Jackie Lynch, and I'd like to thank you for taking the time to listen to my presentation. We're going to be talking about a Cloud 101, where we'll cover an introduction, look at concepts and benefits, and then we'll look at some deployment options and the things you need to think about when you're preparing to move to a cloud environment. We'll also talk about some of the risks and benefits and the IBM Power Cloud, and then I have a few final thoughts for you. So let's start by talking about what we mean by cloud computing. According to the National Institute of Standards and Technology, cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources. That can consist of networks, servers, storage, applications, and services. The idea being that these can be rapidly provisioned without having to have highly trained admins to do that kind of work. Cloud computing is seen as the natural evolution of virtualization, SOA, autonomic and utility computing. Some of the key characteristics of cloud computing include things like agility, low cost, multi-tenancy, performance, and a number of other things that I have listed on this slide. There are many other characteristics as well, but these are just a few. So why do people bother with cloud computing? There's a number of reasons. One of the primary reasons is reduced cost. It lets them reduce both capital and operating costs, and it's a pay-as-you-go type model, so you only pay for what you use. It also allows you to refine how you use people. It basically frees up the admins and other people to actually focus on the business rather than on maintaining hardware and software, keeping it up to date, and so on. It's also highly scalable. You can add resources, you can remove resources depending on what your current needs are. You can also have full disaster recovery, which can help you reduce downtime, and it allows you to rapidly spin up and spin down test and development workloads. Some of the fundamental concepts behind cloud recording include virtualization, scalability, which we've already mentioned, but also manageability is very important. The ability to quickly spin up LPARs, to have things managed automatically, and to be able to get services delivered on any platform. And of course, one of the critical components that I already mentioned is the flexible pricing. So typically we think of cloud computing as three layers. The first one, which is probably the one you'll see the most, is infrastructure as a service, or IaaS. And that's where you get delivered a virtualized platform. You get provided with servers, network devices, disks, etc., and you're responsible for laying down an operating system and for putting on the applications that that operating system is there to support. Platform as a service is where you have an IaaS environment, but they add the solution stack and middleware. So that would include things like MQ, and so on. It makes it much faster to deploy the applications because it provides the application infrastructure. And then finally we have software as a service. Software as a service includes all of the hardware, all of the software, and the application. So examples of that would be QuickBooks Online, TurboTax Online, Salesforce is another very good example. And the provider takes care of everything, application upgrades, the works. This makes it a very easy environment for people to work with. We also have multiple virtualization models. You'll hear people talk about ASP, which is Application Service Provider, or what I just mentioned, which is the software as a service. And typically there'll be dedicated servers for each application when regulations require it. They will also deal with things like multi-tenancy, where they'll have a single instance of the software serving multiple clients. There are issues around data privacy and customizations for that, so sometimes multi-tenancy is not an option for them. We also have the virtualized model, where we work with a virtualized operating system such as VMware, Xen, Amazon AMIs, and then we have hardware virtualization, such as what we get with the power systems, logical partitions, or virtual machines. These can be used for single tenant applications. They can also allow you to have multiple tenants on the same server in different LPARs or virtual machines that are fully separated from each other and isolated. So if you want to look at a traditional ASP or application service provider environment, it's going to look something like this. You'll have a number of tenants, they'll have a presentation layer, business layer, data layer, and there'll be some hardware and operating system layers. And all of that is taken care of by the software as a service provider. You don't have to redesign anything, they have isolation, and they take care of the backup and disaster recovery. But it's expensive to operate, and there's poor scalability, so typically when you're using a software as a service environment, it's going to be a little bit more expensive than if you're using an IaaS environment. When we look at the virtualized model, we have a very similar environment. We have our 3 tenants. They obviously have their presentation, business and data layers, and then they'll have the operating system and virtualized hardware. Depending on whether you go IaaS or PaaS, you will either have to lay down all of the operating system, data layer, business layer, presentation layer, or they will provide the operating system for you and the middleware, and you will have to provide your actual applications. You don't have to redesign applications for virtualization. You get isolation, particularly with power hardware, where the isolation has been certified in many different ways. You'll get more hardware and operating system customization than you get in a shared environment. That allows you to be more innovative in what you're doing. You still have to do backup and DR. Again, it's not as scalable as shared middleware, but it's better than ASP. And there's a higher administration overhead than you see with sharing because you are responsible for doing the administration. So why do people bother going for cloud? There are a number of good reasons to do so. And they come down to things like cost reductions from sharing. If somebody else is putting together all the hardware and software and taking care of the cost from that, then you basically are paying for what you use, and that can save you some significant funds. You can get enhanced security. You can also get much better performance per core, and you can lower your software licensing costs. And then you have availability. You don't have to now pay to set up a disaster recovery data center as well as your regular data center. That's the responsibility of the cloud provider, and you simply sign up for the disaster recovery or availability options that you want. And clearly scalability is an issue as well, and the cloud providers are supposed to provide unlimited elastic scaling as long as you're willing to pay for it. Automation is probably one of the most critical components to cloud computing. In order to be able to do any kind of scaling, in order to have any kind of standardization, you have to be able to automate everything. That means as little manual intervention as possible. That also makes it much easier when you're doing audits and when you're going through process governance, because if everything's automated, then you're able to show them how things are being done from an automation point of view. And all of this, of course, leads into higher quality resources. When it comes to provisioning, one of the things we care about a lot is elasticity. That's the ability to start and stop things. It's the ability to only pay for what you're using. It's the ability to be able to grow and shrink as needed. And you want that to be automated. You want to be able to just go to a GUI and say, give me more, or take away things. But obviously you want all that to be recorded, and you need those changes to be managed. So let's look at what our deployment options are. Fundamentally, there are really 3 deployment options for cloud computing. You have private cloud, public cloud, and then a hybrid. Private cloud is basically where everything's within your firewall and within your enterprise, over your intranet. Public cloud is where everything is provided by somebody else and you access it over the internet. And then a hybrid, which is what we're seeing the most of nowadays, is a combination of internal and external service delivery methods that get integrated together. So you may keep some things inside of your firewall and they talk to things that are out in the public cloud. Public cloud is easy and inexpensive. Hardware bandwidth application costs are covered by the provider. Now if you go IaaS, which is the infrastructure as a service, then the application costs are going to be covered by you. Again, you have the flexible pricing, and IT becomes more of a service. But this is something where you have to have the dynamic provisioning and automation, so you have to have your work environment set up to be able to handle that. And then lastly, we have private cloud, which can be called internal clouds, and that's implemented wholly within the data center. So everything's going to be inside your corporate firewall. There's no multi-tenancy, there's no sharing of anything. Your data is secured within your own environment. Now that can be managed by your own corporation's IT, or you could bring in a third-party cloud service provider to manage your private cloud. So it gives you control while you still get some of the savings. So we talk through the following 3 cloud computing options. Private, where you're the only person on the cloud. It lives in your data center, and of course you have the option of having a private managed cloud where somebody manages your data, and having a hosted private cloud where it's managed by a third party. It can also be hosted by a third party, but you are the only people using it. Then we have our hybrid cloud, which is our shared cloud services. And finally, the public cloud, which is where the general public could be accessing the same servers that you are accessing. Sometimes we call that external cloud, and it's also referred to sometimes as IT as a service. In terms of the layers for clouds, we have multiple layers that we talk about. First is the client layer, which is the hardware or software that depends on cloud computing. We have the actual application, which could be software as a service or cloud application services that deliver software. We have platform as a service, where we get the platform that we want to run on and the solution stack as a service. And then we have infrastructure as a service, which I mentioned earlier, is where we provide the platform and you have to provide the operating system, etc. And then typically what we run in our data centers today is the server, where we have the hardware, the operating system, the databases, all of the middleware, everything else that we are responsible for. So infrastructure as a service is probably one of the more common cloud things that I use. And IBM's Power BS Cloud would be an example of this. It delivers you the computer infrastructure as a service. That means they provide the network, they provide the storage, they provide the SAN switches, all the network switches, they provide the servers, they provide the virtualization. So as an example, you would not get access to the VIO servers, but you still have the ability through the GUI they provide to actually spin up instances and remove instances and add storage and remove storage and so on. So it's really a utility computing option. It provides much easier provisioning of compute resources, and you can easily request and receive instances. It's all a matter of you basically tell it what you want, they tell you what it's going to cost, and you click yes. You own all the security for within your operating system. They own the security for outside your operating system, such as the network switch, the SAN, and so on. Platform as a service is a little bit different because they also provide the solution stack. And it includes that software framework that lets your applications run. You can manage the security for the middleware database and application runtime environments, or the cloud provider can manage the security for the middleware that they're providing. Software as a service is where they actually deliver the software over the internet. And the example I gave earlier was Salesforce. But another good example is Google Docs, Office 365, any of those kind of applications where basically a third-party provider is providing everything from the application down to the hardware. It's typically pay as you go. You can request additional software instances, etc., and you don't need to worry about where or how it will be hosted, although we'll talk a little bit more about that later. And security is fully the responsibility of the cloud provider. The idea being that you can focus on using the application instead of having to provide it, support it, maintain it, etc. So if we take a cloud systems view, and this is a diagram from one of the red books, you could see the different service portals and the cloud service providers. You can see that there's external things you have to take care of, like change and problem management, configuration management. You need to pay attention to metering and chargeback and storage management. Depending on which cloud service that you decide to go with, and again, IaaS, platform as a service, or software as a service, different components of this will become your responsibility. So So how do you prepare to migrate to the cloud? The first step is going to be to analyze your existing processes. There's a lot of people think that you can just decide one day that I'm going to go cloud and they're going to take care of everything. But you need to actually understand what processes you have, which ones can be automated, because if they can't be automated, they probably do not belong in the cloud. You also need to look at what your approval structure is, because delegation is very important. So as you start to provision resources, there shouldn't be the requirement for manual intervention. Somebody should be able to request a resource and get that resource without having to have manual approval steps. And obviously you need to identify security and compliance needs to ensure that you don't get in trouble with any of the organizations that are likely to do audits on you. So part of architecting your cloud is thinking of things that are important to you, such as monitoring tools and standards. What do you use to monitor your systems? What kind of performance reporting do you need? How do you do capacity planning? Do you want to hand those functions completely over to a cloud provider? Do you want to outsource them to somebody else? Or do you want to take care of them internally? You need to have some kind of a service catalog, which is really those automated pieces that you're going to be able to provide through the cloud. And you need to look at how do you plan to optimize your cost and usage, which components need to go out there to be optimized, and which pieces do you need to keep inside. We're going to talk more about data protection, security, and policy enforcement later, but those are obviously critical to when you're architecting the cloud. You need to think about what data you care about and what data that is not as critical in terms of its physical location. And there's also, you need to look at resiliency methods. What are your disaster recovery requirements? Do you need to have disaster recovery such that if something happens on the west coast, you fail over to the east coast, and vice versa? Or is local recovery okay, or do you need no recovery? And then we think about things like billing and cost allocation, and obviously skills. What skills do you have, what skills do they have, and how do you best take advantage of those skills? So as you start to look into the cloud, you're going to have some concerns about security. And one of the first concerns people bring up is the lack of visibility and control. Clearly you're going to be putting your data and your applications in someone else's environment, and they are not going to give you visibility and control of their actual environment, such as their VIO servers, etc. They can't do that because you're in a shared environment. So you need to ask questions about how do they plan to protect your sensitive information. If you have regulated information that you have to answer about, then you need to know how that's going to be stored and protected in a shared externally managed environment. Additionally, you need to know that if, for instance, they decide that they're going to replace the storage and they decide to get rid of some disks or something like that, how do they plan to scrub your data off those disks such that you can be assured that no data accidentally left the data center that belongs to you? It's also important that you ask them about privileged user access. You want to know who has access to your sensitive data and to your environment and where they're located. There are some cases where clients are not allowed to have anybody from outside the US having access to their systems or to their data. So you need to actually know those kind of things, even though they tell you you don't need to know where your data is located. And then lastly, you have the issue of regulatory compliance. Are they going to allow you to do external audits and security certifications? And if so, how does that work? I brought up data location before, but actually it's very, very important to know where your data is stored, because your data could be stored in a different country to where you're actually working. Some of these clouds are I don't want to say multinational, they're international. And the issue you have there is that different countries, even different states, have different privacy laws. So you may end up with your data in a country and not able to get it back. So you need to be very, very aware of where they're going to be locating your data. The same with data segregation. Are they going to be able to provide data encryption techniques if you have the requirement to have your data encrypted in place? And then do not forget recovery. One of the critical items on your cloud plan should be how do they plan to back up your data and your operating systems and to recover them. This is really important if you're in a infrastructure as a service or a platform as a service environment. And I've seen many times where the architecture has forgotten about backups and data recovery. Those should be the number one thing that you're going to ask about. And lastly, security scans. We live in an environment where our security team likes to scan our network regularly and check our systems for services that shouldn't be running. Does your cloud provider do those, and will they provide you with the output? What does your security department require, and how do you plan to deal with those as you move forward? So part of implementing a secure cloud basically involves the things that we all hate: change control, auditing, policies, those kind of things. If you want to build and maintain a secure cloud infrastructure, if you're building a private cloud, you need to look at things like firewall configuration, server security, and so on. If the outside vendor is doing it for you, then you need to ask them about those things. If they're going to make a change to a firewall, do you get notification that this change is happening, particularly if it impacts you? Same with network switches and so on, because a change to a network switch can take you down. You also want to make sure that they have solutions for ensuring confidential data protection. These are the things that I've already been talking about. So it's important that you have a governance audit management program, a vulnerability and intrusion management program, and that the environment is constantly tested and validated. And I already mentioned you might need to know where your data and services are. Can they tell you? I kind of said to somebody joking one day, don't try to tell the SEC that the cloud ain't your data. It's really important that you know whether you care where your data is located or not. And I've already talked about the support people. You also need to think about what is your required response time. Are you going to put that in your contract, in a service level agreement? Also, what are you going to allow them to do from a system management and maintenance planning point of view? So as an example, if they decide that they need to take everything down to put on an emergency patch, how's that covered in your contract? And it's really important to have proactive communication. As I said, you need to be notified about maintenance. You need to be able to monitor the systems and know what's going on. Scalability is one of the main reasons people move to the cloud. They want to have the ability to respond to large volumes of service requests. So as an example, you may have a couple of days of the year where you really have a huge peak workload, and you don't want to be buying hardware to cover that when the rest of the year you don't use it. So you want to make sure that whoever the vendor is that you're working with has the ability to rapidly scale up and down, and that they have those resources available. You want to be able to do that kind of expansion quickly and as inexpensively as possible. And you also want to make sure that as you grow, the systems are reliable and that they also have the ability to handle those kind of service requests rapidly and preferably automatically. In terms of hireability, you're going to be looking for facilities just like you would if you were going to an external data center. You want reliable power, cooling, and you want a reliable network. You want everything to be highly available with an N+1 redundancy. And clearly you're going to want a 24/7 operational capability with a 24/7 help desk, as well as clearly documented failover and disaster recovery plans. And make sure that you understand the implications of different kinds of outages. What happens if the cloud vendor has a local outage, a regional outage, a US-wide outage? What are the different fallback plans and the pricing for each one, and which ones are critical to you that you might want to think about signing up for? And that brings us in to a discussion about the risks and benefits of cloud. So obviously some of the risks are things like insufficient bandwidth, that they just didn't size the network or the storage SAN correctly, or that the provider runs out of resources. So you're at a point where you actually want to scale up and you want to add CPU or memory or disk, and the provider has run out of resources and is waiting on resources to be delivered. That means that you pretty much do have to do some planning ahead. Also, what is the impact of the mishandling your data? If you don't pay attention to your metering and monitoring, then you may end up paying some service charges that you weren't expecting. So as you spin up resources, you want to make sure you get a report so that you know all the things that you've signed up for that you're going to be paying for each month. Some of the things that happened early on with clouds, which have not been so much of an issue recently, have been when the cloud vendors ran into financial or legal problems, or when they had to literally shut down. There was cases where the SEC shut somebody down. You need to make sure that you have a plan for if something happens to the vendor that you're working with. Heaven forbid that happen, but it could. You need to have a plan for that. And that comes down to data recovery, confidentiality. How do you get your stuff back? Which leads to a conversation about lock-in. Is your data and application able to be removed from that vendor very quickly, or are you completely locked in because of the way the applications had to be written? These are all risks that you have to analyze and figure out how important they are to you. The business benefits of cloud are pretty well known. Obviously, we've talked about responsiveness and agility, but it's also the ability for your employees to access your applications from anywhere. They can go across the internet, or you may require them to go through a VPN, but they can now get to applications from wherever they are. It's also nice having incremental pricing, but it does mean a change in how you do your business. We're used to using our capital budget to purchase hardware and operational budget to pay the ongoing software costs. Well, now all of the costs go into an operational budget for the cloud. So you're going to have to make some adjustments to how you do the budgeting. The ability to rapidly adjust the volume of users as your workload increases is a significant business benefit. And when you want to do a new product release, or when you want to do a marketing run, the ability to just spin up resources, as long as you're willing to pay for them, in order to be able to support that, is very, very valuable. There are some IT benefits for cloud as well. It lets IT focus on what they really should be doing, which is focusing on technologies and ways that they can better help the business take advantage of the new technologies. And they can try new technologies without the high risk and cost of having to go and purchase everything. Instead, they can test it in the cloud. It lets them leverage the service provider's expertise, and it allows you to still continue using your existing infrastructure, but you can connect it to the cloud, and then you can take advantage of where things really should be best deployed. So we've mentioned cloud security, and I want to touch very briefly on how power systems actually address cloud security. Power systems provide enterprise level security, and they've met many criteria for security. They've got a very stable and reliable roadmap that goes out for years and years. The Power VM virtualization that they're using has been around for a very, very long time. In fact, I want to say in 2005, I was at a Z-Series Expo and sat down with some of the developers of the virtualization technology for the mainframe. Well, then not that long after that, I sat down with some of the Power VM developers, and it was basically the same people. This is technology that's been around for a long time and is rock solid. There's a lot of built-in reliability, serviceability features in Power, and then we have functions like live partition mobility and also SRR, which allows us to take a downed LPAR if the whole server goes down and move that LPAR across to another system. And we have a lot of automation functions that basically allow us to manage the system and take advantage of automation. IBM also has a lot of offerings in the cloud. Within the IBM cloud, the two that I'm familiar with are the IBM Power Systems Private Cloud and the one I'll talk about later, which is the IBM Power Virtual Server in the IBM Cloud. There's also AIX systems in the Google Cloud now. There's AIX in Azure, which is basically SkyTap. And then you can also get AIX Cloud access from other CSPs and MSPs. They've also brought out a version of AIX, which is an Enterprise Cloud Edition that includes Power VC, which they use to manage the cloud management console, Power SC for security, AIX 7.2, and a bunch of other software that's useful to have when you're in a cloud environment. So let's talk about some of the questions that you need to ask. Do you need to rapidly bring services to market? Are you the kind of people that will suddenly have a big marketing kickoff where you need to have a whole lot of extra hardware and software just temporarily to help with that? Are your resources constrained? Do you have enough people? Do you have enough infrastructure? Can you afford to go out and buy a whole lot more stuff when you need to, or pay more people when you need to? How about testing? One of the most common places that people start with the cloud is actually development and testing, because then the developers can quickly spin up and spin down development environments to try out what they need to try. Which speaks to the next point, where do users need to be able to request and provision environments? Do they need to know the service costs? There's a number of different points on here that you need to think about. And then as we go further down the list, do you have a plan to switch back if it doesn't work? Do you have a plan for if the cloud goes down? I've talked about vendor lock-in before. And then, will one cloud meet your needs? Like, is there one cloud to rule the world? Or do I really need to go to a multi-cloud environment where I have to look at different vendors depending on what it is that I want to do in the cloud? The answer to that is most likely yes, but again, it depends on your environment. So IDC did a management cloud survey on multi-cloud in 2019, and it was of almost 300 US-based enterprises. What was interesting was that 93% of them stated they were using multiple infrastructure clouds. And their primary reasons for going to the cloud was still automation, analytics, and governance. And their most important reason for using multiple clouds, 61.5% of them said it was leveraging cloud-specific capabilities. So it was actually a very interesting survey, and I highly recommend that you go and read it, because there's a lot of information in there that's quite useful as you're thinking about going to cloud. I also found this article from CloudLogic, which was very interesting, and it's a 3-part article, but it talked about what the market share was for the cloud infrastructure services. So as you can see, it's basically Amazon, Microsoft, and IBM, and then Google. And then there's a bunch of others that they've lumped together. So that the cloud market is definitely very, very active, and there are a number of different organizations that can provide what you need. So when you think about clouds, it becomes very apparent that there are a lot more clouds in your life today than you might think. For anyone that plays online games, such as Zynga, Farmville, those kind of games, or even World of Warcraft, any of those are all based on cloud technology. From a business point of view, you have things like Google Apps, you have Office 365, applications like Box, Salesforce, Amazon, all of those are clouds. And you even have the option to basically take advantage of cloud backups. IBM and Azure offer cloud backup facilities, and anyone that has an iPhone is familiar with using iCloud as a backup technology. Now, there are a number of myths around clouds, and I have a lot of them in the next few slides. We're actually going to go through them very quickly because they are myths. But for a lot of people, they think cloud computing solves everything and includes everything, including the kitchen sink. And I think you'll have seen from the presentation so far that in fact you need to use cloud where it's most applicable and where it's most useful, but it is not going to take care of every problem that you may have in your data center. So here are some of the myths. The first one is that there's just one single cloud. All you need is a credit card. It's going to make things easier and you can easily blend things together, or conversely, you'll never be able to blend them. The fact that it's always going to save you money. Now, what's interesting is these particular myths were actually documented in a Business Week article in 2009, and they are still around today. And then the CIO magazine published their top 7, and these were myths about clouds that had to do with the same sort of things. Automatically saving money, you can layer it without changing your underlying infrastructure, it's an easy transition, oh, it's going to kill all of our jobs, and you only need one cloud. And in Gartner's top 10, they had very, very similar myths. And what you're going to see is that there's a theme here. One of the new ones Gartner found was that people think that multi-cloud will prevent lock-in. Every cloud has some things that lock you into that cloud that make it difficult for you to get out. And then the myths that we are probably more concerned about are the ones that talk about the fact that we're all going to lose our jobs. The clouds are free or really cheap, and you're never going to have a problem with performance, and security is going to be phenomenal, etc., etc. Keep in mind that if you are doing infrastructure as a service, you are responsible for the security, you're responsible for figuring out how much resource you want, and so on. Additionally, moving to a cloud does not mitigate your responsibility for an outage. Your clients don't actually care if you are providing resources through the cloud or through your own data center. What they care about is when they come to you, as an example, to deposit some money in your bank or whatever, that it better be there. The real truth is that cloud's a complex resource, and you've got to understand it, and you've got to do a lot of hard work to manage it correctly. Once you get the infrastructure set up and you've done all the planning, things become a lot simpler. There are also legal issues associated with going into cloud that you need to talk about and resolve up front. I've referred earlier to the location and use of data. If your data ends up in a different country, they may have different privacy laws. That can be an issue. You need to understand your obligations and the cloud vendor's obligations. That includes things like the terms of use and reliability. What's in your service level agreement? You want to know who all the parties are in the cloud stack. What are their roles? Where are they based? Also look into things like backup, restore, and disaster recovery plans. And I'm going to give you an example in a little bit, which is an older example, but it really illustrates the issues around disaster recovery. Right, service levels, business continuity, change control, those are all things that are legal issues as well as business related issues that you just need to have in your plan as you go into this. And then I used to tell people the first question I ask a cloud provider is, how do I get my data back? You need to have an exit strategy and you need to understand what kind of lock-in is involved. You want to look at portability. What happens if you want to move your data to a different cloud or back to your data center or even to another system within their cloud? What are your electronic record retention requirements? If you're required to keep certain types of electronic records for 7 years, how is that going to be backed up and archived, and how do you get access to it? And then probably the one that bothered me the most when this all happened early on, and we're going back to 2011, a lot of providers that had started out in cloud shut down. So EMC shut down, Atmos, Vaultscape shut down. A couple of other vendors like Iron Mountain just got out of the cloud business. There were a couple who got shut down. It wasn't their intention to shut down. You need to understand what your options are if that happens, and particularly if they get shut down with no warning. So these are things just to be aware of from a legal point of view that you need to make sure you cover in your contracts so that you have the ability to recover if any of these things happen. And to give you some examples, in 2019 and 2020, this is just a few of the outages that have actually occurred. And you can actually now go to the Google Cloud Outage Detector to find out what the status is of everything in the Google Cloud. Downdetector.com also monitors other clouds. And the big ones of this year were Twitter and Salesforce. Microsoft took an outage. Azure's gone down a couple of times. Amazon, AWS has gone down. And the big one that I'll talk about a little bit more is in 2011 when Amazon did take a very large outage and it took down a significant number of businesses. And the interesting thing that I found was that McAfee did a study in 2019 and they found that 69% of security officers actually trusted their cloud providers to keep their data secure, and 12% believed that the cloud service providers were solely responsible for securing data. Unless you're in a software as a service type scenario, you are responsible for securing your data. It is not the cloud provider's responsibility. So be very aware of that and make sure that you have plans for that. So even though this happened in 2011, which was 9 years ago, I want to talk a little bit about the Amazon outage because it's a very good example of making sure you understand your service level agreements. So in the case of this outage, there was some kind of network configuration change made, and it caused pretty much their East Coast data centers to go down. At the time, Amazon offered different kinds of disaster recovery, and some of that resiliency was if you were based on the East Coast, you would fail you over to another East Coast environment, and then if you paid more money, you could have fail over to the West Coast. So a lot of people just did the East Coast failover, figuring if a data center went down, they'd fail over. Well, in the case of this outage, the Elastic Compute Cloud did not go down, but the block storage and relational database service did. And what people found out very quickly was that their contract only covered if the Elastic Compute Cloud went down, which it didn't. It was up, you just couldn't get to it. And it didn't cover any of the data services. And so the learning piece from this was, number one, make sure you understand your SLAs and how the disaster recovery works. If you have critical business infrastructure in any of these clouds, you need to make sure that if half the country goes out, that you can fail over to somewhere where you can continue working. You also need to look at the price of service. Price of service isn't everything. Just because you can move to the cloud and do it cheaply does not mean that you shouldn't look into the disaster recovery possibilities and make sure that you have rock solid disaster recovery for your critical workloads. And that's what the key message from this was: design for failure. When we do things in our data centers, we look for N+1 hardware. We look for software like vMotion or LPM or PowerHA that allow us to move resources around. And we look for redundant resources. And what we're adding to this with the cloud is availability zones. Just like when we do disaster recovery ourselves, we will try to have failover to a data center that is less likely to be affected by the kind of things that affect us. So if we're in a hurricane zone, then we'll try to make sure our DR zone is not in a hurricane zone, and so on. And that's really a critical point, is you need to make sure that you have that kind of stuff designed in right up front. And now I want to talk a little bit about what do you look for in a cloud service provider. We've talked about all these different things you need to make sure of that are in your contracts. So we're looking for certifications and standards. We're looking for technologies and service roadmaps. How quickly do they bring in new technologies? These are all things here that are motherhood and apple pie, so to speak, but they're things that you would normally talk to about anybody that you're going to do business with. And so these are things you should look at with the cloud, adding in things like the vendor lock-in, exit planning, and migration support. So what you want to make sure is that you're not the person that just goes, you know, we're just going to throw everything up in the cloud. You need to make sure that you do the proper planning, just like you would if you were bringing in a new data center. So I want to finish up by talking a little bit about the IBM Power Cloud. IBM offers a lot of different cloud solutions, and in fact they have a multi-cloud solution which really involves different kinds of clouds within their environment. The one that I've been doing work with more recently is the IBM Power Virtual Server on IBM Cloud, and so I'm going to focus on that, but there's a number of other different cloud options listed here that you may be of interest, and you can go to the IBM website and they will have detailed information on all of these. So the IBM Power Virtual Server Cloud allows you to run AIX, IBMI, and Linux workloads on Power in a public cloud. And typical use cases, it started out with people would move in there with just testing environments and maybe development. And then because IBM has multiple data centers around the country and they're starting to have them around the world, they added disaster recovery. And now more and more I'm seeing mission critical workloads being moved into this cloud. So IBM's Power VS Cloud is actually an IaaS, Infrastructure as a Service. They provide either S922s or S980s. In Washington, D.C., it's an E880 right now being migrated to a 980. And you can get cores on that, you can get memory, you can get storage and everything else. And it's a self-service environment, so basically you log in once you get everything set up, and you tell it you want to spin up an LPAR, you tell it how much memory and CPU you want, you actually go and you create all your LUNs, basically from the GUI, just saying, you know, I want 10 100 gig LUNs, whatever it is you want. It comes back and says it's going to cost you this much a month, and you click on yes or no, and then it creates it all for you, and then they will provide some base level operating system images, or you can use your own. So it's multi-tenant self-managed. By that we mean you're not going to get access to PowerVC, you're not going to get access to Novalink or the VIO servers or anything like that. Your access is going to be through a GUI, and then depending on what network options you sign up for, you can use SSH to get to your LPARs and so on. So it's a very robust environment. When they have issues, they will LPM you to another server and so on. What it allows you to do is grow at your own pace. There's no heavy upfront costs. You basically sign up and you start to deploy your LPARs. It's very rapid growth when you need it, that you can scale, so an LPAR can start at one size and grow, and obviously you pay as you use it. It allows you to run your workloads wherever you want to run them, and it's very flexible. They also offer some things like disaster recovery as a service, backup as a service, all of those kind of options, but you need to make sure you build those in as part of your planning. And you can have IBM fully manage it, or you can use self-service. So my experience with it has been, for the most part, very positive. There's a couple of things I find frustrating. One of them is that the default console that you get through the web browser doesn't allow you to copy paste. So it's the equivalent of logging onto an HMC and using VT menu, and then you can get in and you have a proper console, but you don't have the ability to copy paste. So if you're building things in an LPAR and you use scripts and things, you're going to have to type them all in. The other thing you need to plan for is external access. You either have to VPN into your data center and have links set up between your data center and the cloud, or use a jump server that you order and have set up that you log on to, and then you can get in from there. That you can add public network access to your LPARs, but the default level that you get is fairly slow, and you need to actually sign up for additional public network access to get the high performing stuff. Now, when you get into this, it's important to have a good networking person in the design and planning. Without planning, you're going to miss some steps, you're going to miss some connectivity. You need to plan for backups and be very upfront about whether you're going to do your own backups or you're expecting IBM to. The web-based interface is incredibly easy to use. It's very easy to add resources. I went into it completely cold and managed to figure it out and got a bunch of LPARs up and running very fast. But as I said, it's IaaS, so you're responsible for the operating system and all of the stuff that runs on it. There is a ton of documentation available, and if you're interested in doing this, I would ask about the workshops that IBM sometimes offers that cover migration. So some final thoughts. Cloud is here to stay. It's not going anywhere. You can implement it safely and securely, but you need to plan, and your network skills are going to be critical. And we've talked at end's length about understanding backup options and DR and what support is provided. You need to understand all of those things and have a plan for them, and you will have an incredibly successful implementation. If you skip the planning steps, it's going to be a lot more challenging. So I'd like to thank you for attending this session, and I hope that you found it useful. If you have any questions, please don't hesitate to contact me. I've got my email address here. And I hope that you all stay safe and enjoy the rest of the conference. So again, thank you very much and have a great week.